Hello and welcome back to Maths Bites. This is the second video in the binary numbers series, but the first video was only an overview of the different topics we will cover. So this video is the first where we get to do some maths. In this video, we will become more familiar with indices, the exact vocabulary used with these mathematical concepts, some special indices that are important. Then we will focus on two types of indices we need for the binary numbers. I will show you plenty of examples throughout the video, and I also give you the opportunity to practice the newly introduced knowledge to make sure you fully grasp this concept that lies at the heart of every number system, including the binary. So, let us get started. Indices are also called exponents and powers, so you might have already come across this concept under another name. However, in computer science, they are mostly called indices or exponents. Now, what are indices? Well, indices are a mathematical shorthand for writing repeated multiplication of the same number. For example, if you wanted to multiply 3 by itself 8 times, you would take quite some time to write it out. So a shorter way of writing it is 3 with a little 8 up in the right-hand corner, which is read 3 to the 8. Remember, mathematics is a very precise subject. When you write something differently, it will mean something different. So make sure you don't confuse 3 to the 8 by 3 times 8. 3 times 8 is also a shorthand notation, but it is shorthand for repeated addition. 3 times 8 is the same as adding 3 together 8 times, while 3 to the 8 is 3 multiplied by itself 8 times. Now, let us look at some more examples of this notation. What would the following indices mean? 2 to the 5 is 2 multiplied by itself 5 times. 7 to the 4 is 7 multiplied by itself 4 times. And 10 to the 7 is 10 multiplied by itself 7 times. As some of the lower indices are used quite commonly in everyday life, they have their own special way of reading, saying them. Anything to the second index exponent is called squared, and the third index exponent is called cubed. For example, 3 squared and 2 cubed. You will hear me using squared and cubed throughout the rest of the videos. Let us now discuss the exact mathematical vocabulary for indices, exponents. Two numbers are involved in this concept. The big number is called the base, and the small number in the top right-hand corner is called the index, exponent or power. The base tells us which is the number we will multiply together again and again, and the exponent, index, will tell us how many times we will multiply the number together. For example, 2 to the 5, we will know that 2 has to be multiplied together 5 times. Now let us practice these new concepts to make sure you fully understand them, and you will know what I mean by them when I will use them throughout future videos. I will stop talking for a few seconds so you can try to identify the base and the exponent index in the following examples. So, the bases are 5, 7 and 12 respectively, and the exponents indices are 2, 3 and 5. I hope you got all of them right, but if not, don't get discouraged. Making mistakes means you are learning something new. Now that we know what indices are, and we also know the correct vocabulary for them, let us discuss some special indices. The indexes 0, 1 and the negative indices have special meanings. Any base raised to the 0 index is always equals to 1. Here are some examples. 2 to the 0 equals 1, 10 to the 0 equals 1, 125 to the 0 equals 1. Any base raised to the first index is the same as the base itself. For example, 2 to the first is equal to 2, 10 to the first is equal to 10, and 125 to the first is equal to 125. Negative indexes are the same as 1 over the positive equivalent of the same index. For example, 2 to the negative 2 is equal 1 over 2 squared. 10 to the negative 5 is equal to 1 over 10 to the 5, and 125 to the negative 3 equals 1 over 125 cubed. Hopefully, you have noticed that I was using some mathematical notation in brackets when I was explaining these special indices. Let us take a closer look at them before we move on. In these notations, I use the letter B to represent the base that can be any number. In mathematics, when we want to emphasize that in a particular case any number can be used, we use letters instead of a number. When using exact numbers, we just show one exact example and not demonstrating that the concept we discussed is true for any number. In the last notation, I used n in the index when talking about negative indices. Again, in this concept, the exponent can be any negative number. In mathematics, it is very common to use the letter n to represent any number, as the word number starts with n. I couldn't use b again, as it would indicate that I would have to use the same number in the exponent as in the base. In mathematics, if the same letter used again, this is an indicator of having to use the same numbers. So anytime you want to emphasize that you can use two numbers which might be different, you should use two different letters. There is absolutely nothing special about using b and n in the above examples. I could have used whatever letter I wanted to, but I like using the b to draw your attention to the role of the number. Some textbooks might use a in place of b. The meaning is still the same. Now let us practice some of these new indices. Try to answer the following questions while I stop talking for a few seconds. Also, feel free to pause the video here if you think you could work better without the time pressure. Here are the answers. Allow yourself to make mistakes so you can learn without unnecessary extra pressure. In the last segment of this video, I would like us to apply the knowledge we learned to two bases we will use throughout the binary number series. These bases are 2 and 10. There is absolutely nothing special about these two bases, so everything we learned can be applied straight. Let us look at the following examples. 2 to the 0 is equal to 1, 10 to the 0 is equal to 1, 2 to the 1 is equal to 2, 10 to the 1 is equal to 10, 2 to the negative 3 is equal to 1 over 2 cubed, 10 to the negative 5 is equal to 1 over 10 to the 5. Now let us summarize what we covered in this video. We have discussed that indices are a mathematical shorthand for multiplying the same number by itself repeatedly. We have also established that the number that gets multiplied is called the base, and the index exponent represents how many times we will multiply. For example, 2 to the 5 means that we multiply the base 2 5 times, where 5 is the index or exponent. Next, we looked at what the 0, 1 and negative indices exponents mean. Any base raised to the 0 index will be equal to 1. Any base raised to the first index will be equal to the base, and any base raised to a negative index will be the same as 1 over the positive equivalent of the index. For example, 2 to the 0 is equal to 1, 10 to the 1 is equal to 10, and 5 to the negative 3 is equal to 1 over 5 cubed. Then we took a little detour and discussed some generic mathematical notation that is commonly used with indices. Lastly, we looked at some examples of these indices where the bases are 2 and 10, which are the numbers we will be using throughout the binary number series. Now, I hope you have learned something new and useful about indices in this video. Also, feel free to rewatch this video if in a future video you came across these concepts again and you are no longer confident in their meaning. When learning something new, you have to practice it more often until it goes into your long-term memory. So I would suggest you try some more examples similar to the ones we practiced in this video. In the next video, we will be looking at the decimal number system in more details. Until then, keep learning one byte at a time.